What's up, Soul Squads? Today we're going to talk about graphing exponential functions. So the first thing we need to understand is, when do we know that a function is exponential? Well, we know that when the input, our x value, is on the exponent. So that's your key goal. So then we're going to write it like this. So we have a, h, and k. That's what we've been focusing on with transformations. But when you see this x value is in the exponent, the input's in the exponent, that we know that has to be an exponential function. So how does an exponential function look like? Well, the parent function, remember the parent function is no horizontal shifts and vertical shifts and stretches or any transformations, which is just b to the x, where the a value is 1, the h and k is 0. Well, you have a horizontal asymptote. That's a new term that we're going to talk about today. I call it HA. Horizontal asymptote. It's pretty much, I try to think of it as a road, like a wall. You cannot go through it, so it just blocks it. So your graph will start close to it, and then it'll go up. This is called an exponential growth. So exponential growth. The reason why we have this horizontal asymptote is, the question I always ask is there any way we can make your output, your y value, be 0? Or is there any way to make your output, your y value, negative for your parent function if we plug in any value for x? So give me a value of x that will make this whole thing 0 or negative. So some of you guys might think, well, cool, b to the 0 power should give me 0. But what is anything to the 0 power? Anything to the 0 power is 1. So that doesn't work. So that actually gives us a key value there, 0,1 is your Y-intercept. And some of you guys might think, well, let's put a negative exponent. Negative exponent, what does negative exponents do? It actually reciprocates it. Watch my video on properties of exponents. That'll help you with all the rules on that. So there's no way that we can get to 0, and there's no way we can get to negative with the parent function. Obviously, if we shift values up and down with my k value, it will change it, but for our parent function, there's no way. So my parent function looks like this, and you have the horizontal asymptote telling you that you can't cross here. There's no way my output would ever be 0 or will ever be negative. Growth, we also have decay. We'll talk about how we get that. Decay looks like this. Same thing as 0,1. So let's talk about this. This is exponential decay. So growth occurs from my b value, this guy here. This guy tells you if it's a growth or a decay. All right, it's growth or a decay. So how do you know if a growth if the b value is greater than 1? So the b value is greater than 1. It's our multiplier, so it's going to continually grow. If my b value is in between 1 and 0, so a fraction, not an improper fraction, but just a fraction, like 1/2, then it will be a decay. All right. When we talk about the difference between exponential and linear, linear, it's constant rate. So the slope is continually going at, you're adding or subtracting at a constant rate. So for example, if I take 1 step every second, I'm only taking 1 step every second, so we're going increasing as a line. So it's constant rate of change. If you talk about exponential growth, what's happening to this a value? We're multiplying. So 2, if you multiply something that doubles, then 1 becomes 2, 2 becomes 4, 4 becomes 8, 16, 32, 64, and so forth. So our multiplier, which to me I like to call it the b value, is going to be, it's going to tell us that it's an exponential function. So the b value is important because it tells us if it's a growth or a decay. The a value, if it's negative, it reflects. If the a value is greater, it becomes more stretched. So it's increasing at a faster rate. And if a value is getting smaller, then it's going to grow at a slower rate. Think of like money. If you put $1,000 in a bank and you're multiplying it by 10%, you will make a lot. But if you start out with the bank with $1, that interest of 10%, you're not going to make that much, so it's going to take longer, so it's wider, versus $1,000 will be a lot quicker. So we're going to do a couple examples with exponential functions, so let's get ready for that. All right, our beginner problem. I want you to tell me if it's a growth or decay? Growth or decay? So your first problem is y equals 2, 3x minus 1 plus 4. B is y equals 3, 1/2 x plus 2 minus 3. So I'm going to give you about 30 seconds to a minute. Try your best. Don't just tell me if it's growth or decay, but also write y. So let's write that. Growth, decay, and y. The y is important always. Explain to me in words, why is it growth, why is it decay? Go. Alright, welcome back. Let's try this. The first one, growth or decay. What is it? It's a growth. Why? Because you're multiplying it by 3. Your B value is 3. Think about if you have $2 and you're multiplying it by 3 every time. When you're multiplying something, it gets bigger, bigger, and bigger. So it's a growth. Here, it's 1/2. It's a decay. Why? Because the B value is a fraction in between 0 and 1. But what happens when you multiply 3 by 1/2? What does it mean when you're multiplying something by 1/2? You're technically dividing it by 2. So what happens when you're dividing something? It gets smaller and smaller and smaller. Think of like a slice of pizza. If you're cutting it, you have one hole, and you start cutting it in half. Now you have 2, and it's less slices. The size of the slices gets smaller, so it's decaying. Right, check your answers, make sure you understand growth and decay, not just that the B value is greater than 1 and the B value is in between 0 and 1, but really understand why it's doing that. Alright, good job. Let's try our intermediate problem. Explain the transformation. So the A, H, and K, tell me what's going on. Also tell me if it's growth or decay. Let's get a little bit of practice. So if I give you this guy, let's try this guy. Let's do positive there. So 2 problems. Tell me every transformation that's occurring. This is always important because it's a good way to check your answers when you after you grab. So that's our advanced problem. So try this in about 30 seconds to a minute. Go. All right, the first one, what's going on? We have A, H, K, so it's a vertical stretch. Also reflected, so reflection, vertical stretch. How do you know it's a vertical stretch? If the A value is greater than 1, you're stretching it. The vertical stretch, if A is in between 0 and 1, it's a vertical compression. It's a decay. This is your H value, plus 4. Remember, it's opposite H. Go watch my videos on quadratic in vertex form when we talk about transformations. So this is left 4, and this is down. Your K value is your down 5. Part B, it's positive, so there is no reflection, so you don't have to write anything. 1/2, so it's a vertical compression. It's a growth. -4 is right 4 now, and then up 6. So we're going right 4, up 6. This K value is also your horizontal asymptote. Think about it. If you have a horizontal asymptote and we shift everything up and down, it's going to also shift your horizontal asymptote as well. Okay, check your answers. Make sure you got all of them. See how much you got. Let's try our last problem. Y equals 2, 3, x plus 4. Alright, so graph it, try it. I would always start your horizontal asymptote, which is your K value. Start there, put your horizontal asymptote there. Plug in points, maybe 1 or 2 points. But if you know it's a growth or decay, you can kind of sketch that out. So I'm going to give you about 30 seconds to a minute. Go. Okay, let's take a look. So right now I know my K value is 4, so I'm going to start it up 4. So that's my horizontal asymptote because of this 4. I'm going to plug in a couple of values and see where it's on the graph. I like to always find my Y-intercept. To find my Y-intercept, you let x equals 0. So you plug in 0. Let's do this together in our heads. I do this a lot with my kids. 3 to the 0 power is what? 1. 1 times 2, 2. 2 plus 4, 6. Let's try that again. Anything to the 0 power is what? 1. So all this becomes 1. 1 times 2, 2. 2 plus 4, 6. We get 0, 6. We know it's a growth. So we should plug in a couple more values, but my graph should look like this. Okay. Last little part, domain and range. Domain is how far left, how far right my graph goes. How far left does the graph go? It travels to negative infinity. How far does the graph go to the right? It travels to positive infinity. So you can write all reals, or you can write negative infinity to positive infinity. My range talks about how far down your graph goes, how far up it goes. It's not all reals because we actually stop somewhere. Where do we stop at? We get closer and closer to our horizontal asymptote, which is 4. And how far up do I go? So how far down do I go? It gets closer and closer to 4, but never touches 4, but goes also to positive infinity. All right, check your answers. This is how your graph should look like. If this was if it was a fraction, then it would go the other way. But we always start at our HA. All right, so that concludes our lesson with graphing exponential functions. Hopefully these videos are helping you guys. Please subscribe to my channel, turn on your notifications, and let's get ready for some more videos.